Hello and welcome back to another episode of Math with Sohn. Today we are going to be doing some permutations and combinations, which sound intimidating, and in some cases they will be, so I'm not going to lie to you there. But they are pretty easy. It is important to distinguish what is the difference between a permutation and what is the difference between a combination. So we have several examples to help figure that out. A permutation, the order matters. Whereas a combination, order no matter. The order does not matter for a combination. So the order will only matter for a permutation. For example, okay, if you are making soup is an excellent example of a combination of ingredients. Okay, does the order matter in which order you put the soup in? No, you're going to put your broth in and you're going to put your carrots in, and it doesn't matter. They're all going to get put together. Okay, so the order doesn't matter. Now, don't take into consideration that cooking would actually mean that you got to put the carrots in first because the carrots take longer. Don't worry about that. They're all going in the pile. Order doesn't matter. That's a combination. Whereas a permutation, the order would matter, and that would be for things that, let's say you are, first, second, and third in a race. It doesn't matter which that you all finished. It matters who got first and who got second and who got third. That would be a permutation example, okay? And in all of these, the numbers can get quite big. They can get quite big indeed, okay? So don't think the numbers are going to be small. And because the numbers can be really big, means that we will typically have to use a button in our calculator, okay? So here, we're going to do number 2. I'm going to do the even ones on this particular sheet. 3 out of 19 students will ride in a car instead of a van. Doesn't matter what order they got in. No, they're all getting in the van, okay? Oh, excuse me, they're all getting in the car. So 3 people are getting in the car. This is a combination. It does not matter what order they get in. They're all getting a seat, okay? So we will have to do a button in our calculator. Now, depending on what calculator you have, will determine how you're going to have to do it. So I'm going to start with the most typical calculator. Hopefully you have a graphing calculator. If you don't, I hope you have a scientific calculator, hopefully one that has a PRB button. So if you have a graphing calculator, you have to hit the math button, unless there's a different shortcut, but I don't see one. So we hit the math button. The math button's right here. And then you cursor over to probability. And then you see NCR and NPR. Well, what did we say this was? We said this was a combination. So we would have to hit the NCR button. Okay? So, reiterating, I'm going to do it again. Math, cursor over to probability, and then you can cursor down to NCR. And it will have 2 little cursors here. Now, personally, I always forget which one goes where. I know I'm going to have to put a 3, and I know I'm going to have to put a 19. So let's just try 3 first, and then 19, and see what happens. It ends up equaling 0, which tells me I did something wrong. Well, the good news is with these problems that it doesn't matter if you get it wrong, because you can go back and you can change it to 19 NCR3, and that is 969 ways. What that means, because this is all like a random number to you right now, that means there are 969 ways that 3 people could be picked for the car instead of the van. So if you had 19 of your friends, we can call them A, B, C, D, all the way to E, F, G. We can name all the friends. I could pick D, C, and B to be in the car. I could pick E, F, and G. I could pick A, B, and G. I could pick 969 different ways, which would be impossible to list out, which is why we have the button in the calculator. Okay? So, to reiterate, you put the bigger number first. Bigger number first, then the smaller number. Bigger number first, then the smaller number every single time. But if you mess up, it'll tell you 0 and you know you messed up. All right? Then, for if you have this calculator, you could hit the PRB button, NCR, and then you need to cursor over and you would hit 19. Apparently it goes away. Probability, NCR 3, and it would tell you the same number. So PRB, you got a cursor 19, and when you cursor 19, it disappears, which is really annoying. And then I go back to PRB, hit a 3, and I get it. Okay? So, let's do another one. Wilbur and Ming are playing trips to 8 countries this year. There are 10 countries they would like to visit. They are deciding to skip which countries to skip. Okay, so there are 10 countries they would like to visit, but they are planning 8 this year. Does it matter what order they go in? Probably not. There might be like, oh, well, I don't want to visit, England in the winter, but not the order doesn't matter. So this is, again, a combination. So we are going to do 10 NCR 8 because we want to go to 10. There are 10 to choose from, and we're going to visit 8. So we just do that. We go math, we cursor over, we pick the NCR button. I like the graphing calculator more because I can type a 10 and then I can hit the 8, and I can find out that I only have 45 ways that I can do this one. And that's because I'm visiting almost all of them. Out of the 10 that I want to visit, I'm visiting 8 of them. So I only have to eliminate 2, which means that I have a lot of combinations, but I still am going to only miss out on 2 of the things. So I don't have near as many combinations as I did on the first problem. Okay, let's do a few more. We got 160 people meeting at random. They will shake each other's hands with everybody else. How many handshakes were there? Ooh. Well, this one's a little tricky. I think I got it. I know it's a combination because it doesn't matter what order they go in, I believe. So with that being said, there's going to be a lot of handshakes. So let's think. We know we're going to have 160 first. How many people will you be shaking hands with? I think you're either going to be shaking hands with 160 of them or 159, because do you count yourself in that? So I'm going to try it. I know what the answer is, and then we're going to think about it for a second. We got probability. We got 160. Is it 159? No, that doesn't feel right. 160. Is it going to be... How many handshakes were there? They each exchange with somebody else. So 160 people. Takes 2 people to have a handshake. So it might be 80. Let's try 80. Oh boy. Let's see. 80. Well, that's a really big number. That seems a little too big. Any other ideas? I think the 159 wasn't right. 160. NPR. Maybe it's a 1. Or maybe it's a 2. Because it takes two handshakes. There we go. I think I got it. Apologies. These all take thought. And they're not all done the same way. That, I believe, was it. It was. Okay. Got it. So, NCR 2. Well, why is it 2? Because everybody's going to be having... You got to have 2 people to make the handshake. That one was a weird one. I'm sorry for a bad example. Some of these are not perfect. Okay. I wanted to do number 8. I wanted to do all of them up until number 10 for this part. We got number 8, the batting order. Finally, something where the order would matter. This was a combination, in case you didn't know. Combination for number 6. Number 8, the batting order. Does it matter the order in which people line up for bat playing a baseball game? Absolutely. Because if you line up first, you're not lining up second. And it would matter the order. So number 8 is our very first permutation. And guess what the difference between permutation and combination is, other than the order matters? Order matters for permutation. It matters because now you just use a different button. You use the NPR button. So we are going to be picking 7 players, so we need to do 9 NPR 7. And when you're doing these, please, please, please type what you would actually have. So I didn't do it here. Type what you put in your calculator. 10 NCR 8. 160 NCR 2. 9 NPR 7, okay? So 9, math, probability, we go to NPR for the very first time, and then we hit a 7 because we got 7 players, and this is a whole lot of ways that you could line them up. 181440. Wow. Okay. There are 50 applicants for 3 jobs: computer manager, software tester, and manager. is this going to be a situation where the order matters? If you get picked for computer programmer, are you going to be able to be picked for software tester? No. So the first person they pick, if they pick the first person that applies for the job and they pick them to be a computer programmer, that means the other two can't be a computer programmer and the order would matter. And this means that this would also be a permutation. If you get those wrong, they get confusing. Good news is it is a 50-50 guess, okay? But this would be a permutation, and most of the time you'll have more obvious things for permutations and combinations. So be aware of that. 50 NPR3. We type that in our calculator. I'm just going to use the button that I already had, and I type a 50 and then a 3. I cheat the system, and I get 117,600. Okay, we are halfway through today's lessons, ladies and gentlemen. The next part, good news, is easier. Okay, we are just determining if it is an independent or a dependent event. Independent or a dependent event is much, much easier. Okay? If it is an independent event, excuse me, the first event has no impact on the second or the third or the first. If it is a dependent event, the first event will impact the second or the third and or the fourth, okay? So if you flip a coin, we're doing number 12, we're still doing the evens. If you flip a coin, if the first one lands tails up, will that have any impact or will have that any influence whatsoever the second time you flip the coin? No. You can flip a coin heads, you can flip a coin again, and you could get heads again. It's a 50-50 every single time. It is a 50% chance every single time, and because it's a 50% chance every single time, and because the first event has zero impact on the second, this is an independent event scenario. Okay? Let's move right along. A basket contains 7 apples and 5 peaches. You randomly select a piece of fruit and then return it to the basket. Then you randomly select another piece of fruit. The first piece is an apple and the second piece is a fruit. So you got a basket. You take out an apple, you look at it, you're like, ooh, pretty apple. You put it back. If you put it back, has anything changed? No. Because you put the fruit back, now you have the exact same total that you had the first time, so this means that the second piece of fruit could have been an apple or a peach the exact same way that the first time did. So this is still an independent event. If you did not put the fruit back the first time, then it would be a dependent event. So let's say that you had a whole bunch of fruit. If you took the apple out, now you have one less apple in the basket. So if you go in to reach again, the likelihood of you getting an apple now is a little bit less because there's less apples in there. But in this case, you put it back. Because you put it back, then it would be considered an independent event. I might be doing 13. Yeah, we're going to do this one. So it says you got 15 bottles of sports drinks. 8 are lemon lime, 7 are orange. You grab a bottle. You give it to your friend. Then you grab a bottle for yourself. You and your friend both get lemon lime. So if we have, how many? 8 lemon limes. So we got lemon, 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 and 7 orange. Orange, 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 orange. If I grab a lemon and I take it out, I had a 8 out of, how many total were there? There were 8 out of 15 were originally lemon lime. I've taken one out. How many do I have the second time? There's now 1, 2, 3, 4, 5, 6, 7 lemon limes. So the second event, the first event, I had an 8 out of 15 chance because there were 8 lemon limes. The second time, I've taken out a lemon lime. I only have 7, and it's not even out of 15, it's out of 14. So it's a different probability for the second pick, which means that this is a dependent event. Dependent. Wahoo! Flipping the page. We only got 2 left for today. 2 left for today. Whew. Whew. Then we get to these crazy looking problems for tomorrow, okay? A bag contains 6 red marbles and 6 blue marbles. You randomly pick a marble and then pick a second marble without returning the marbles to the bag. Notice how it says without returning. That means that the first pick would be different than the second pick because you have removed some. And that means that the total is now a little bit smaller. This would be the total and you took away one, so this would be the total minus 1. So the new total is a little bit smaller. So that means that these are dependent events. Okay? A bag contains 3 red marbles and 3 blue marbles. Another bag contains 5 green marbles and 5 yellow marbles. That's just a lot to read. Okay, you randomly pick 1 marble from each bag. 1 marble is blue and 1 marble is yellow. Okay, so let's think about this for a second because thinking matters. First bag we have, that's a terrible looking bag, would you agree? 1 bag contains 3 red and 3 blue. So red, 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 blue, blue, blue. You could also say 3 red, 3 blue. You don't have to write out that. Another bag contains 5 green and 5 yellow. Another bag, 5 green, 5 yellow. I'm not gonna write out 5 Ys. If we draw from the first bag, I draw my, what am I drawing? I'm picking 1 marble from this bag. Let's say I draw a blue. If me drawing a blue from here, will that impact what I draw from the other bag that's sitting over here by itself and has nothing to do with this first bag? No, it won't. So I would have, let's say I wanted to draw a blue. I have a 3 out of 6 chance of drawing a blue. Well, will that impact my chances of being able to draw a yellow out from this bag that has nothing to do with this first bag? No. That means that these are independent events. Woohoo! Independent events. Okay? That's going to do it for this video. We're at a 17-minute mark, which this is not going to take you the rest of the period unless it's a Wednesday. So I would recommend maybe watching part of this other video that goes into how to do determining if events are independent or not using an equation, which is also pretty easy until you get to the bottom part, and then it gets a little harder. Okay? So the next video is going to be short, and if you want to watch that, if you feel like you're up to it, go ahead. But until next time, stay positive, my friends, and I will see y'all later. Bye.